All right, so hopefully you guys have watched the video. I didn't have a notes packet, and so you have to use Miss Miller's note pack, or excuse me, her video for now. But I'm gonna go through some of these and just figured I would make a video of it so that if you're struggling at all, you can watch and kind of see how I'm doing my problems. So don't make any of this harder than it is. Basically, in calculus, there's a lot of different language and notation, but the math is not anything new. This one is asking, in the graph below, find the slope of the line between each pair of points. One of the ways we can do that is to find y2 minus y1 over x2 minus x1, which you've been doing since, I don't know, algebra 1. Or the other thing you could do is you can count, up 1 over 1, up 2 over 1, whatever it's going to be. So whatever you're most comfortable with. So from A to B, looking for the slope. I can either take A as 1, 1, B is 2, 1, 2, 3, and then I can do y2 minus y1 over x2 minus x1. I'm just doing these values. That'll give me 2 over 1 or 2. Or I could count. Remember, you always want to count from left to right. So in this case, I'm going up 2 over 1. So up 2 over 1 would also be a slope of 2. We'll do one more. How about from B to C? Here's B, here's C. So those are kind of a unique pair because they are horizontal. If you remember the slope of a horizontal line, great. If not, you can use your points. B is 2, 3, and C is 4, 3. So when I go to set that up, y2 minus y1 over x2 minus x1, I get 0 over 2, which is just going to be 0. So the slope of that line connecting them is 0, like any horizontal line. So then you can tackle those two on your own now that you are an expert. Here's where we get into a little bit of calculus. It says find the slope of the tangent line, and this should be at each point. Slope of the tangent line is what you do the majority of the time in calculus, and it takes on different meanings. What that means is like a tangent line is one that just grazes past the graph at that point, only touching in that one spot. So at x equals 2, here's the point they're talking about. So I'm going to use my handy mail, which is laying on my counter. And I'm going to try, like I can't go up higher and I can't go too low because I start hitting other parts of the graph. So I just need to sneak past it, which looks about like that. And it's always kind of a guesstimation, so you do the best you can. That would be the tangent line at x equals 2. And if I'm looking at this, it kind of looks like up 1 over 1, up 1 over 1, up 1 over 1. And so I'm going to estimate the slope of the tangent line at that point to be about a 1. All right. Then how about at, let's try, I'll give you a couple to do. Let's try at A. Here's point A. So another way they could have asked is what is the slope at x equals -1? Because at -1, the graph is down here at point A. So now again, like here, I can't aim upward or I'll hit other parts of the graph. So you have to stay on the exterior of the graph and just kind of scoot past it here. So this would be my tangent line at point A because it just grazes and touches right at A. So this one, it looks like goes down 1 over 1, down 1 over 1. Maybe this one's down 1 over 2. I think that's closer to down 1 over 2. So I would say my slope for that tangent line is about -1 over 2. So you want to do two things in terms of showing your work. You want to draw the tangent line that you got and then list the answer that you got for the slope of that. These are all just kind of preliminary skills for finding derivatives and doing calculus. This goes back to algebra 1. The notation is just, this is the function. What do you get when you plug in a 2? So you would literally just say, okay, f of 2 is going to, and then you look at the rule, be 2 squared. So if f of 2 is going to be 2 squared, my answer to that is 4. And that's read f of 2 equals 4. Meaning, when you plugged in a 2 to function f, what do you get? So I feel like you can do these. Here, don't make this harder than it is. This is saying when you plug in an x. Well, it says right here what happens when you plug in an x. Using this function, you get out an x squared. This is asking you to plug in an x plus 1. So now you have to use your math skills. If I'm going to do that, where there used to be an x, I'm going to have an x plus 1, and it's going to get squared. Keeping in mind that means that I would have to multiply it by itself, which goes back to FOIL. So I'd end up with x squared, 1x on the outside, 1x on the inside, and then a 1. So f of x plus 1 equals x squared plus 2x plus 1 because these are alike and can combine. Then the next one wants me to plug in an x plus h, which seems really super weird. Grabbing my power cord, sorry. But the x plus h is going to lead us towards some notation in something called the difference quotient, which is tied to derivatives. So this is asking me to go back to this function, and wherever there's an x, plug in an x plus h. So I'd have x plus h quantity squared. Just like the one above that, I have to multiply it by itself. Oops. Then I'm going to need to FOIL it out. So first, outside and inside, each of those would give me an x times h. And then my last two terms would be an h squared. So just like the example above, putting together like terms, I get x squared plus 2xh plus h squared. So I'm just kind of practicing some skills. They're going to be really foundational for me to do some derivatives. Derivatives use this as a part of their definition. This setup you should have seen in Algebra 2, but maybe not very in depth. This is called the difference quotient. Quotient, if you remember, means that it is a fraction or division, and difference is a subtraction. So the difference quotient is this, and this is going to become a really key thing for us in derivatives. So we have to learn how to simplify these out. I already did this in question 13, so I'm going to kind of cheat and use this part without redoing that work. So I have an x squared plus 2xh plus h squared. That's this because I already did it. And then I'm supposed to subtract f of x, which is the original function. And in this case, I don't have to distribute that x to any, or excuse me, that subtraction to anything else because that thing only has one term. And then over h because that's what I was given. Then you simplify. You look at the top. I have an x squared here and a negative x squared here. When you're working with this difference quotient at this stage, you should be able to cancel everything out except for the terms that still have an h. So this is an h, this has an h, this has an h. So my next move is always to take out that h. Up here, that would leave me with a 2x. Because that h was squared, I'd still have one left there even though I divided one out. And then I have the h on the bottom. So that's why you always want to have h's here if you've done it correctly, because now I have this h on the top and the bottom, and they can cancel out. That's going to become really important when we get to derivatives. So then my answer to this whole thing, this difference quotient, would just be 2x plus h. Seems weird, but it's a foundational skill. Now, I did all of these problems for you because this bottom is a repeat. So the only thing different is that this function is a little bit trickier than the one that I did. So between what you saw in Miss Miller's video and this, hopefully you can finish off some of these others. I'll be obviously focusing on the ones that I didn't do when it comes time to check these. But follow my steps here and just take a little extra time, because keep in mind that when you get down to here, you have to put that x plus 1 everywhere there was an x. And then here, x plus 1 is going to be squared. So this is just going to turn into a few more steps because you're going to have to distribute the 30. You'll need to square this and then distribute the -4, combine like terms, and so on. So take your time. This is pre-calculus. It's really the very beginning of calculus, especially this difference quotient. This will follow the same pattern. You'll have your answer from the previous one. You put that there. Then you'll subtract the original function, which you already know is going to be the 30x minus 4x squared because they told you. So whatever answer you have will go here, minus, and then this is that f of x, the original function, keeping in mind that this time this negative is going to distribute to both parts. Once you have it simplified to this place, everything should cancel except the terms that have h's. You'll be able to pull an h out from everything in the top and cancel it with the one from the bottom, and whatever you have left is your answer. So use these examples that we did together to help you with the bottom, and then you'll be an expert on day one. Have at it, my friends. Bye-bye.